Oh my god, that's hilarious. Okay, let's see. Let's try this again. I don't know what caused that. I'm going to blame Windows 10 because they're always a low-hanging target. I have no idea. I think the only thing I did different this time, I swear to God, is that I slept my machine instead of rebooting it before this. I turned it on before the stream. I had a bit of an audio issue with Wavelink, Elgato Wavelink, but I resolved that. It was just like, something happened out of order. I have no idea. So I don't know what caused that. I apologize. I thought about giving you guys extra time, but then I'm like, you know what? Maybe I will. I don't know. We'll see how I feel at 5 p.m. 2 hours is still a long time as it is. So anyway, welcome to the unscuffed version of Technical Wednesdays. Still playing around with this idea, see where it goes. There is a lot of deep knowledge that needs to happen with regard to the Avalanche network, and consensus is only one small part of it. We built a platform, and as with any platform, the user base needs to be educated on exactly what that platform is and what it means, how they can build in the ecosystem that we've set up. Platforms are a means to launch your own applications. A lot of the applications you've been seeing lately are C-chain oriented, but I'm saying a lot. There's a ton. Mixing up my words a little. There's a ton of features that are underexploited, underutilized in the system. And I feel like the secret sauce to all of that is to explore some of the APIs of Avalanche, as well as some of the transaction types that are available in Avalanche. Sort of explain to you the design theory behind the UTXOs of basically the transaction types in Avalanche, like how we are actually producing state changes on like the X chain and stuff. And this is going to be a little dry for some people. So if you're used to like the Tuesday or the Thursday chat, it's going to be a little less interesting than that. But I'll tell you what, I have no problems going through Avalanche.js with you in detail. In fact, it might be really essential for what we're doing today. The question is, actually there's no question. I can just tell you how it was done. Honestly, it's not that complicated. Once the principle, like the very basic tools used to design things was created, it's pretty straightforward after that. The hard part was getting the framework going. And the other hard part was like testing. It's the hardest testing I've ever had to do for any application ever. Simply because, and I probably missed things like this. It's very possible I missed testing edge cases in Avalanche.js. But the reason that it was so hard is because working with binary in JavaScript sucks. Like, bigly. It sucks. Like, first off, JavaScript is every number in JavaScript is a floating point number. But it's even worse than that. It's not like you can get 2 to the 64 space in that. It's actually 2 to the 53. And there's no way you can do any 128-bit manipulation or 256-bit manipulation in JavaScript. So you have to work with these libraries called buffers, but unfortunately buffer was written for Node.js, and it had to be shinted over in something called buffer, which is another library, and like there was no standard way to do this. And the real reason that was a problem is because Avalanche transaction formats are canonical. So I'll get into that in a bit, but that's just a preview. First off, I want to just point out again, chatdocs.avox.network is the source for everything technical with regards to Avalanche. It is the place you go when you have a question. And you try and solve that there first, and you could go into, if you have problems after that, definitely go into the Discord chat, which is chat.avox.network. And it'll load you up in Discord, so you should be good then. But this is the place you go to kind of start with a platform and get a real idea of what's going on with the platform. So a lot of people know already what staking is and what the Avalanche consensus is. We've been over that quite a bit, okay? One of the things that hasn't been... What is blockchain basics? Oh, these are linking to articles and actual... Okay, cool. One of the things that hasn't really been explored a lot is the transaction formats and the transaction types. And so the reason I'm going to the transaction fee section right away is to point out, well, first off, we have different fees depending on the transaction type. And I think a lot of people might know that already. But some some transactions are actually just straight up free. So let's talk about the design philosophy around transaction fees really quick, because it's pretty straightforward. If value in the network is like, the reason for a transaction fee is to sort of stop flooding. So the network can't just be flooded with transactions, and it's really important because we go so fast. We don't want that to like bog down the nose. It's kind of like a limiter on how fast things can go in the network. That's one functionality of fees, okay? And it's really important because without that flood protection, natural like fee-based flood protection, you know, you can't, like, if somebody's willing to pay for a ton of transactions, they should be able to do it, right? That's the way we kind of look at it. But if you're just trying to like hurt the network, the fee stops that. You'll be doing it at your own cost, right? But there are certain transactions, 2 of them exactly, which streams as dependable as a C chain during a liveness failure. Yeah, F you, Don. I'm trying, man. I'm trying. I'm actually going through Wi-Fi, not wired in, just because of the way where my wireless routers, where my router is actually like positioned. So it's as good as I can get it for now. But yeah, no. So I just want to point out that add validator and add delegator are both free, and the reason for that is because of the design philosophy around these transactions. Is that you would need to commit at least 25 Avox to be staked up for 2 weeks in order to add a delegator, right? There's a huge cost already associated with that. It's an opportunity cost that you lose by staking. Now, it's not necessarily an opportunity cost because the opportunity itself is staking and delegating. You actually get an ROI on that. But you'd actually be locking up those funds. So why are we going to charge you for those transactions? Really interesting. Anyway, in general, there's that. There's also the whole simple send on the C chain. The C chain is measured in gas, C-chain transactions are just like Ethereum, so they have gas costs associated with them. That gas cost is currently 225 nanoavox. A simple send is just a straight 0.004725 avox, which is good to know that you have that flat fee. It's a little more expensive than a normal transaction. I think part of the reasoning behind that is we don't want the C-chain to be leaned on as hard for simple sends. And that makes sense to me. It's kind of like it's kind of, it's also, and the other reason, of course, is because that's how much it costs on Ethereum. So because we have this net gas price of, or this base gas price of 225 nanoavox, okay, that times 2100 gas is equal to exactly that. That's how that price is made. Makes perfect sense. But at the same time, like, C-chain should not be used for just plain transactions. If you're just doing back and forth, like A sends to B, at high frequency especially, you want that to be done on the X chain. And the X chain is still kind of a mystery to most people because they're so used to Ethereum. They're leaning on the C chain for every operation, it feels like. Not everyone. I know it's not every operation, obviously, but for the most part, people are really using the heck out of the C chain. And a lot of that's because there's some lack of education and mystery around what the X chain is, what it does, and why it was built the way it was built. So part of the way that I know how, the only way I know how to remove that mystery is to do a little quick tutorial stream, I guess you could call it, on what the X chain is and how it bundles transactions up and how you can interact with the X chain instead of interacting with the C chain. And I think you'll find that it'll lower your costs and increase your throughput, which is what everybody supposedly wants. They've said that for a long time. That's what we want. We want that from Ethereum. We want to lower our costs and increase our throughput. Okay, well, I know that people don't like that. The fact that there's no smart contracts on the X chain, but most simple transactions do not require a smart contract. I think you can lower costs by doing a lot of the basic work on the X chain instead of the C chain. And the cool thing about the X chain is you can batch exchanges of items in a way that you cannot on the C chain, because the C chain is the account model and it has a specific way that it does things. It doesn't allow you to batch transactions in one transaction very well. You know what I mean? You can do it in one command. It's not the same thing as what the X chain does. So I want to go over some of the transaction formats on the X chain and really help you guys understand that. I also want to point out the types of transactions. There are different types of transactions, okay? And that's why I brought you to this page, is that the P chain and the X chain are both based off the UTXO model, and they also have this concept of transaction type, meaning that an actual transaction is not on a C chain, on the Ethereum chain and the C chain, in any Ethereum chain. A transaction is basically a transaction is a transaction. You have little fields you can add to a transaction to give it additional features, but ultimately, transactions each transaction basically has those fields innately, kind of. But in the X chain, it's actually more rigid, and that rigidity enables faster parsing, faster building, easier to check. It'll fail faster. It'll fail sooner. If there's a malformed transaction, you'll notice it quicker, which is why it's more high throughput than on the C chain. But the difficulty with education comes in that people need to understand that there's different types of transactions on the X chain, rather than one type which could have very many different fields, like on the C chain or any Ethereum chain. There's different types. And so on the X chain, I'm going to show you right now, we have this fee schedule. And on this fee schedule page, which you can get to by going to docs.avox.network, you can actually go to the sidebar right here and see that if you go to platform overview, transaction fees, it lists this fee schedule like right here. And so the fee schedule for C chain is very straightforward. Like I said before, everything's based in gas, and the simple send always costs 21,000 gas. So that times that much nano Avox equals 0.004725 nano Avox, I should say, in order to do a simple send. But you see here, there's all these other transaction types available to the user when they are actually building a transaction in Avalanche. And two of those transaction types are add a validator and add a delegator. And I pointed out before, they're free because they have a cost associated with them, but everything else has pretty much the same flat fee, except for create an asset, which has a higher fee, and create a subnet, and create a blockchain, which also has a higher fee. So now I'm going to talk about why those two have the higher fee over the others. When you create a blockchain, you're adding data permanently to the chain, and this pays for that permanent add. We want a higher cost associated with that. We want it to be serious. Personally, I think state rent would be an awesome way to do this, but to get things off the ground, the basic way to do this is to have a higher fee associated with stuff that has permanent storage. Ethereum does this too. A single store on the Ethereum blockchain, I believe, costs exactly this much gas, if I'm not mistaken. It's been a while, I don't remember, but I know it's a lot more gas than a normal operation. So a single store operation has a high cost for it on Ethereum. Same is true for us. To create a blockchain, you're actually creating a hash and you're storing it. And so there's a higher cost associated with that single hash being created and stored forever on the chain. The same thing's true for create asset. Same thing's true for creating a subnet. You're creating this permanent piece of data which resides on the chain. So there's a higher cost associated with that permanent piece of data. That's basically, those are basically the only changing costs associated with anything else. Otherwise, we got this import of Vox and export of Vox on the P chain. Very common operations. You've seen it in the wallet before. If you're staking, you got to export from the X chain and import onto the C chain. It's a two-step operation. So you're like export, import. Same way in the reverse, you got to export from the P chain and import from the X chain. You see both of those also exist with the same fees as everything else. They're just simple transfers. The only difference is there's an export cost on the P chain and there's an import cost on the X chain. So you're actually paying double the amount of fees. So you pay the first fee to export on the P chain and then the same fee again to import on the X chain. Other transaction types talk about minting assets, sending assets. These are all the kind of basic operations you need when you build transactions. And these transaction types are all associated with the fee. So the fee structure is attached to a transaction type. So what is a transaction type? Let's go over a bit of the reference, I believe. And you could get into the AVM transaction format. Now the thing to ask right now is, what the heck is the AVM? Everybody knows the EVM at this point. It's the Ethereum virtual machine. Well, the AVM is the Avalanche virtual machine, and it is what powers the X chain. The AVM is a very high throughput capable machine. Obviously room for optimization, but optimization and principal design are two separate things. And this is a very principled high throughput machine. It can go faster than what it currently is. It's not blocked, right? It's got a lot of ability in the way that this design from the VM standpoint stands to grow. It can be extended. It's extensible. It's built in a way that can have new transaction types added as new needs arise in the network, and it's not tied to any one way of designing a new transaction, except for some of the base level stuff, So it has a lot of capabilities to grow in a way that's very manicured. It's a topiary of a machine. You sculpt very specific transactions. They're all transactions. They're all little trees. But you sculpt them in exactly the way that you want to do it. And it's got a lot of flexibility with regard to that. So this is what the Avalanche virtual machine is. It's very, very cool design. We'll see where it goes. Right now, I think there's a lot of room for growth. The cool part about it is it's multi-signature, so you can have different types of signature schemes, be it BLS, quantum safe, or just what we have right now, which is SecP 256K to match Bitcoin and Ethereum. So it's got a lot of capability to grow, like it really does. So it's exciting in that respect. But it's a little complicated for people to come right off the nowhere wagon and understand the actual guts of this machine and why it operates the way that it does. So the key to really understanding this from a user's perspective is to go bottom up and really just get what a transaction means and what it looks like on the AVM. So the AVM is a UTXO based system. The X chain is UTXOs. Yeah, Sangren, thank you for the pump. I appreciate that. The X chain documentation is pretty well done. I mean, it takes a lot to document this kind of work. It does. It's very consistent. Obviously, there's probably a couple things that we miss along the way, but for the most part, it's been very, very well done. I think Dan Lane had a huge part of this. Steven had a huge part of this. I had a huge part of this. Gabriel had a huge part of this. We all really pitched in to get the documentation for this stuff going. A lot of it was easy because we just documented as well. Once we got the documentation off the ground, we documented as we changed things, but then we also, since everybody in the company used the stuff we were also documenting, it made it easier to sort of adjust what was basically just say like, oh yeah, this was unclear to me, and then make it better because we were all also using the documentation that we were also writing. So it's very cool. Don Wanton, long term, do you think it's better to have a lot of data on the X chain or split up the functions of the subnets? For example, an NFT-specific subnet. I do. I actually advocated for an NFT-specific chain on the primary network. And the reason I did that is because I wanted to have... I felt like NFTs had different storage needs than regular system. But I got overruled, and so we have this very generic machine that does a lot of everything. Another reason for that is because I did want the flexibility to pull NFTs on the X chain into a subnet if necessary, or make them optional in some way, because I don't know if the long-term proposition for NFTs will be on the primary network or not. And I wanted the flexibility to be able to sort of like pull that out, considering that there's forever growth on the NFTs. NFTs don't have a way to be pruned that I know of. So, that kind of to me felt like it was something that would be wouldn't necessarily need to be a base primitive, but would also be necessary in order to get the network off the ground and used long term by a lot of people. So I believe that NFTs were necessary. I didn't know if they should be in the same VM. This was kind of overruled. I think the reasoning is because, first off, it's harder to maintain multiple VMs. Second off, it's straightforward to pull deprecate NFTs and move them in somewhere else if necessary. Whether or not the community wants them is kind of going to be the question. And also, there's a probability, now that I think about it afterwards, that NFTs could be a primitive format for exchange. So if you want to exchange an NFT between subnets, it's much better to have that primitive available on a on the X chain as an asset ID, so you could do that exchange and that transfer. I think that the X chain is showing itself to be a very good exchange mechanism for the highest level of security on the network. So NFTs on the AVM might make sense in the long run. My only problem is, again, they don't prune, and I don't know if that's going to be that big a deal or not. I just felt like they had different storage needs. Maybe not. Maybe I was wrong. Who knows? Anyway, so let's see. All right, so let's talk about like what a transaction actually is. Okay, transactions are things that mutate the state of the chain. Okay, and the state of the chain is the UTXO model. I don't think we have a really good explanation of UTXO somewhere, do we? I don't think we do. And I think a lot of that might be because, they already exist somewhere. I don't know where. So, all right, well, whatever. I don't see anything that really just like outlines, hey, this is what a UTXO is in our documentation. I think part of that might be because people might already be expected to know that, unless there's fixed asset. So yeah, I don't see anything that might do that. So basically, a UTXO. I was hoping for a picture or something I could use to help explain. I might just Google it rather than go to our docs. But UTXO is a standard way of doing transactions. You'll see it on the Bitcoin network, and you don't remember seeing that in a doc? Okay, so yeah, what is a UTXO? So UTXO stands for unsigned transaction output, or unspent transaction output. So a UTXO is the taking an output. So just consider UTXOs as like a list of balances, okay, and owners. It's basically what it is. It's balance and owner, right? And it's not spent. It just exists in the chain. And if somebody wants to spend it, they sign that UTXO, which is called an output. It's an unspent output. And they make it an input of another transaction. So you go, this UTXO that exists in the chain, I want to spend it, okay? And I'm going to use it as the input. And let's just say it has 10 Avox in it. And I'm going to send 3 to Bob, 2 to Alice, it's 5. Let's go with 4 to Charlie, and I'm going to burn 1. A whole of Ox, right? Where that input is the original UTXO of 10, and it creates a ton of more UTXOs. These are your unspent transaction outputs. These are outputs of the transaction. And so you'd create a transaction that has the 10 and me as the owner as the input, and then as the outputs, it will have Alice for 3, Bob for 2, and Charlie for 4. But there's a remainder, because 4 plus 3 plus 2 is equal to 9. So what happens to that remainder? Well, that remainder is burned. It's burned. It means it doesn't produce an output. It's actually legitimately no output claims that, which means that old UTXO is consumed, and 10 was consumed, 9 is produced, but 1 is just gone from history. It's burned totally. That's what a burn actually is. So you're actually like taking that change. Just imagine just taking your change when you go to the store, and you say, give me change for a 10. I need a 5 and 4 ones. You take 5 ones. You take that 5, and you take the 5 ones, and you take one of those ones and you set it on frickin' fire. Now you have $9 in your pocket. That's literally what happens in that case. So, do UTXOs refer each other via hashes or some sort of indice? Yeah, they do. So I'll show you that. But basically, that's what a UTXO, that's literally what a UTXO is. And it creates a sort of like, tree where you have multiple inputs and multiple outputs, okay? And you can have multiple inputs. Like you could consume more than one UTXO in a transaction, okay? So that's what a UTXO is, and the X chain uses a UTXO model. Okay, so every transaction that you have, well, because no text editor, because that means that 0x address, first off, why would we? That's the better question. Like, what benefit do you get for having a 0 address? So no text editor is asking, why not implement burn via sending to the 0 address? Which, by the way, I almost freaking forgot. I can't believe it. I was going to send you the link to get on today. He's our guest. So I messed up, and since we had all that technical problems, I forgot to reach out. That is so rude of me. I apologize, dude. So I'll tell you what. I'm going to give you that link. And you can just pop on that anytime you want. Okay, and when you pop on, I'll mute you. But yeah, so we're gonna talk with no text editor a little bit. Don't want to dox you, so I'm gonna let you say your name. Don't know how you feel about that. Cool. Okay, sorry about that, guys. Man, it's been a really... Aphex Monkey's right. It's a technical what is it? Technical malfunction, technical difficulties Wednesday. Yeah, transactions are well, no, transactions are smaller, and that's good and all, but like I don't feel like that's a big deal. It just doesn't help. Like it doesn't add anything to the 0. By sending something to a 0 address, you're just making an address that's vulnerable to attack. Although it's really going to be weird if somebody actually gets that 0 address and then upsets the economy. But literally just burning it means that nobody can ever get it ever. You don't ever have to worry about some weird technological, like maybe we could create a burst of CPU power, CPU compute power for less than a second, and that compromises that address somehow. Like, what if it's like too many weird what ifs there. It's just not necessary. That's the way I look at it. There's no reason to have a zero address. It doesn't really bring anything to the ecosystem, and you could also just make up your own zero address, and also nothing's stopping you from sending to a zero address. But a burn is just better, like all around. So when you do a transaction in Avalanche, you could do that for every address then, I suppose. The other thing is, like, the state history is a send to that address now. So if you have a state history, it's so I guess this is where Aphex Monkey is correct in some respect. If you're keeping track of the entire history of every transaction on the network, whenever you burn, and if you're burning by sending to a zero address, that counts as a send, which now is kept forever for no reason. It brings no benefit. A better thing to do is just not have it. Nothing's stopping you from sending to a zero address. Let me put it to you that way. You can do that right now, but why? And so if you actually go to the transaction fees part, one other thing I want to bring up is that fees are burned. And so when you actually create a transaction, what you're doing is minusing this from the outputs. So all the outputs you create are just missing that little amount, and they're just not going to, it's just going to be the leftover change. Kind of like a sales tax, right? Which actually you pay, but you know what I mean. Contracts in the EVM have their funds moved if you know the private key. Yeah. Anyway, so let's go back to the transaction format. So I want to talk a little bit about that and get us kick-started off of that before I pull on Sangren onto the call. Oh, not Sangren. No text editor onto the call. Ooh, I see you don't have video. Ah, that's right. I was going to dial you in, right? That's fine. Oh, there you go. How's it going? It's late over there, isn't it? Okay, cool. So, let me go back to this. Cool. All right. So I want to talk a little bit about the transaction format first and kind of give you an overall idea, and then we'll head back to it after we talk to my friend here, and we will go over some of his work, which is absolutely incredible, because Hassan has done some amazing stuff, and I want to really point it out to you guys. But the overall transaction format for Avalanche is that you have this concept of a overall asset ID, which contains, so this is actually not what I want to show. Let's see. Where is... Ah, here we go. It's all the way at the bottom. So we got this concept of an unsigned transaction, which is kind of like this general wrapper for all transactions, okay? And this general wrapper has the transaction type, which prefixes it. It has the network ID. So it actually literally says this transaction can only be executed on this network. So you will never have an actual test network transaction that can execute on main network. It has a blockchain ID. So it actually says, hey, this blockchain is the only place this transaction can occur. So it literally restricts this transaction to that blockchain. And it has a list of outputs and a list of inputs. So the outputs come before the inputs. And then it has a memo field, so you can actually add 256 bytes of data to every transaction for a memo. So like this transaction came from Coinbase. This transaction came from Binance. Government on brink of bailouts for banks, or whatever that quote is. Chancellor on brink of bailouts for banks. These are all memos you can add to the field. And these are all things that kind of wrap every transaction. So you got this concept of an unsigned transaction, and it takes a bunch of UTXOs as inputs. and it produces outputs or new UTXOs as outputs. So it's literally like a machine that just takes inputs and outputs, and you're building that little machine, and then there's something that kind of like executes that and produces new outputs as a result. Those outputs that could then later be consumed as inputs to the next transaction, and so on and so forth. It's really cool. It works really well. It's very clean. It's a little harder to work with on the dev side. And by a little, I mean a lot harder to work with on the dev side. And that's where Avalanche JS kind of came in. I am pretty decided at this point that I'm a half hour behind, and I'm probably going to have to go over my time, by the way, at 5 p.m. or 5 p.m. my time, which is about an hour and a half from now. Let's see. It's about an hour from now. Whoa, I'm definitely over time due to the technical difficulties earlier. So I'll probably stay late to make sure that we get this information out there. Anyway. So that's basically the sum of how an unsigned transaction is built. And then the question is, what do you do with this unsigned transaction? Well, of course, you sign it. And so I want to point something else out, is that there's a codec ID, which is prepended to every signed transaction. So I guess from the outside in, you have a signed transaction, and then it contains an unsigned transaction, and then it contains basically input to output types, signed transferable output types, and then that has then credentials on the bottom. So it's like this stacked cake of like actually the signed transaction itself has the credentials on the bottom. So it's like this object in telescoping in way of building transactions, and that's kind of the concept that I think people will have a harder time to construct or build themselves, unless they kind of get that intuitive way of doing things. And I think it's interesting to note that our docs actually put this kind of bottom up, where the most important things are at the bottom of the docs. And I don't think you can see that because my camera's in the way. Let me see if I can help you. Nah, I can't. But UTXOs are at the very bottom of the list of the docs, and the signed transactions come right after that, and then unsigned transactions come after that. So it's literally like we're going bottom up even in the docs. We have this concept of what an output is, and then we have the signed transactions for that out. How do you sign a transaction? And then you have what is an unsigned transaction, and then you have all the different transaction input types and output types and all the credentials types and all that stuff right above it. And so the docs actually make it a little interesting if you're coming in new, just because of the way that things are constructed. I'm not sure if that was intentional or not. It is something to consider. So, but yeah, if you start from the docs from the bottom and work your way up, you might have a better time understanding what an actual transaction is and what it looks like. Thank you, Dan Cryptos, for following. I really appreciate it, man. So this is where I might start when we get off the interview. Actually, I think I'm going to start down here and work my way up. So that's what's to come. But first, I want to introduce Hassan. Now, Hassan is known as No Text Editor on what's it called? On the Twitter and in our chat. And he's done some amazing work lately with analyzing Avalanche in general. And I think I just really want to give him a chance to kind of talk about his work, where he's gone with it, what got him interested in Avalanche, and see, what he's got cooking up for us to come. So, hey, Hassan, maybe you can introduce yourself. Can you hear? Oh, no, I can't hear you. Hold on one sec. Let's see if I can figure this out. Man, this is a scuffed stream today.
Can you hear me?
Oh, now I can hear you, but I bet you can hear me too. So let me... There we go.
Oh, echo.
There we go. That should fix it. Can you guys hear me?
Anymore.
You can't hear me anymore. Okay, hold on.
You're gone.
Where can I hear you?
Maybe the speaker.
Oh, there we go. There we go. Nope. That's still doesn't.
You have muted me, looks like. Hello? Ping.
Okay, you can hear me? No? Alright, this is not good. I'll fix this in a sec. Man, this is a bad stream day. I'll tell you what. I'm trying. I mean, you can hear me on Twitch, right? If you were on Twitch, you could hear me just fine, I guess? No, because that'd be a delay. All right, so let me try this.
I can hear you.
Oh, you can? Okay, I can't hear you. That's the problem.
My mic is running, I think. Just a second.
Okay,
Can you hear me now?
I can hear you. Can you hear me?
Hello?
I can hear you, yeah. Oh man, this is not a good day.
You.
I'm trying so hard, guys. I'm trying. Can you hear me?
I got.
Oh yeah. I got this right before. I don't know what's going
I
on.
can't hear you anymore.
Okay.
Hello?
Okay. You can hear me now, but I can't. Oh, I know what I can do. I can hear you. Can you hear me?
Yes?
Okay. Wow. I wound up being a combinatorial problem for all these inputs and outputs I got going on. Okay, sorry about that. I will need to add that to my loads. Oh, it was on your end? Okay.
I think it was my thing. Yeah.
Okay. When guest enable mic. How's the stream though, guys? Are you hearing me a ton? Probably not, right? Stream should be good. We all good? Everybody good? You good, Hassan?
Yes, I'm fine. Good.
Okay, man. Thanks for coming on the show. I really appreciate it. So you and I have been talking for the past, 2 weeks mostly, like pretty regularly, talking about Avalanche and helping you kind of understand a little of what you've been seeing. I'm really impressed with your work. So anybody who's not been, anybody who's been kind of like following me has seen him in chat. But what Hassan has done is some really impressive research with regard to Avalanche, and I really wanted to take a time out and give a nod to that research. But about 2018, when Avalanche first came out, you went and did some analysis to sort of figure out whether or not Avalanche was legitimate. And
yes.
And you were skeptical as heck. And I'm going to link some of that analysis here. It's in your GitHub. Let me pull that up.
Yeah, I just dropped it into the chat.
Oh, fantastic. Thank you.
Yeah.
So what you found was actually pretty good stuff, and I wanted to kind of get your read on how you came to look at Avalanche to begin with, and, you know, what you found.
Yeah, I mean, I was watching some YouTube show. It was in Turkish, and suddenly, you know, there was this Bitcoiner or some coiner who was doing interviews, and suddenly Emin popped up. And I think, when was it? Maybe 2007 something. And this is a classic scheme with the algorithms. And I was immediately. I mean, I knew Emin from his Bitcoin comments and Ethereum comments and DAO comments, so I took him seriously. But I didn't really know him, or you know, that he was into karma and all the other stuff. So when he explained this scheme with how you can quickly synchronize people, get to consensus, an entire stadium of people, that really fascinated me. So I went and did my simulation there. You see it there, and then I posted about it. Just let me drop the.
Your blog link was really useful. I think that in 2018 you produced some really good work on your blog that I saw very early and was impressed that somebody had already gone out and done this so early in the process. If you don't mind, I'm going to share my screen. Oh wait, you're going to be muted if I do that.
I just tried to find just a second. Where was it? I will drop the link so people can have a reference there.
So hold on one second. I actually want to test something. Can the audience hear you if I have screen share up? Can they hear you?
I'm talking. Can you
I think they can hear. I think they can hear you. If they can't hear you, they'll tell me in a second. But I believe that that they can hear you still with the screen share up, and because I can hear you. And so I just want to point out. So you could keep going. So I'm gonna go through some of your work while you're talking, if that's okay. I've got to set up a screen share plus.
Right. Yeah, I mean, it was after this interview, and he explained how he can quickly synchronize an entire stadium of people to get to the same color. And Avalanche, the base algorithm is so straightforward, right? So I could actually quite understand what he was trying to tell. So I went and implemented the Python implementation and tested if what this guy is telling is really true. And I vectorized it. The entire simulation is in NumPy for those people who are, who are familiar with NumPy. And it allows to implement very fast simulations for 10,000 or 100,000 or a million, people or /nodes. And I did that, and it was just working. You see the graphs. Then I produced those graphs. In those graphs, you see, on the x-axis you have these rounds where per transaction you have this consensus rounds, these consensus messages. And here I think I have 9 samples in these graphs. I didn't know how many samples you guys were going to choose. In the current implementation, you guys subsample, I think, 20 pieces. And I subsample in these graphs 9 pairs. The vertical axis is the consensus layer. And each of these graphs is for 1,000 simulations, because if you have to do multiple simulations to create these what was the name, box plots, to get these variations, and because it's a probabilistic algorithm, right?
So you have to literally test like thousands and thousands of times just to get a good idea if it's actually working. Yeah, got it.
Yeah. These simulations are really, really fast. I mean, they take only a few seconds, and that's the reason I can scale them up to million nodes, and I can simulate, from one sampling just a single pair to up to 9 or 20 pairs. So that's what I did. And you see the graphs, they're just going up. Up.
The more samples you did, it seemed to improve the time to consensus, it looks like, right? The number of rounds to getting it to a confident consensus. I'd say like right here, for instance, like on round, let's just say round 10, around sample 10, round 10.
Yeah.
You start really approaching
10,000 nodes, right?
Yeah.
And you see those little circles. These are the outliers. These are the cases. These are the laggards. Out of these 1,000 simulations, you have those then which didn't make it to full consensus. So there you see, for example, if you have graphs where you have these outliers below, that means you didn't do either enough rounds or you didn't do enough subsampling. And in these graphs, I was choosing 13 rounds and up to 10 subsamples, because in the interview, Emin had mentioned these numbers, or he actually had mentioned 13 rounds and 8 subsamples. And you see, you got even with those numbers, the number of outliers is minimal. Out of these 1,000, you have maybe 8 or so outliers. So in the actual implementation, you have like 20 rounds and 20 subsamples, in which case you get 0 outliers, really. This is, by the way, not the
this outlier around 13, this is
Hello?
a big deal. Can you hear me? Yeah, this outlier
Yes.
around 13, this is a big deal. We don't want any outliers. Like, that's the point of consensus. We
Yeah.
want to reduce this all the way up. So if you add more rounds to this, the chance of this little circle happening goes away. As I think what you've shown here is that you see all these outliers like on 13 on sample 4, right? And then you go to 13 on sample 5, and you go to you see it as 6 gets. There's less outliers on 6's round 13, and there's even less outliers on 7's round 13. And as you go up, there's less outliers on round 13. Now, if you've increased the number of rounds, what this shows that if you increase the number of rounds, you decrease the number of outliers. And in our current implementation, the default number of rounds is 20. So what I think you've shown is that you can actually say to some high level of certainty that you will not reach outliers at level 20. The odds of that happening are so statistically astronomical that it almost becomes irrelevant.
Yeah, and I believe it's actually almost zero, or maybe probably even zero, because you see you have this envelope of outliers below. So the envelope of outliers which go up, and at some point you simply don't get any more any outliers. So in this sense, you just sample enough rounds, and then the network is just doing what it is doing. But of course, this is the base. This is the simulation for slush. This is not Avalanche, right? So this is slush. This is a probabilistic simulation there. And in these graphs, I didn't have an error model either. So in this case, all peers are cooperating.
Okay.
But I mean, this was enough for me. This is the same graph, just in histograms. Same thing. The box plots are, I think, show more. But this was already enough for me to believe, that Avalanche has huge potential, because the base idea, it's so simple. It's essentially, this epidemic protocols where you gossip, everybody gossips with each other, and where you very quickly reach a quick consensus. When you look at the link I sent you on Avalanche Sim, there you see a simulation with the top one with 20 rounds, and you see after. And here I have this error model, which is not Byzantine but faulty nodes with 15%. And it's an SVG.
Little tiny.
You will have problems.
Okay.
Or the second in the second.
This is fine. You can see it on the actual page itself, I think.
Yeah.
I can zoom in like this.
Yeah. Below. Exactly. So you see, it's just reaching 85% very quickly after the third round, and just stays there. It's crazy how fast it is. And I zoomed in the image below. You see it's the same thing, just zoomed in. And if you look at the vertical axis, you see everything is tightly around 85%. I just configured that 15% of the nodes will just not cooperate. They're not Byzantine. They don't try to actively hurt the other nodes, but they simply don't cooperate. And you see, after 3 rounds, it's just flat and very stable. And this is for 10,000 nodes, by the way, not 1,000 nodes. What we have in the main net.
Now, keep in mind, this is the number of nodes is technically irrelevant to the number of to the whole situation, right? It grows without. Well, I mean, it does actually mean it is relevant. I guess it's a log of the nodes. But the point is that it's not like that big of a scaling factor in the system. It's still approximately the same number of rounds will still come to the same conclusion. And the other point I want to bring out is you've put 15% error, which means 15% of nodes were just like randomly not cooperating. They just weren't cooperating, which is more of a crash fault tolerant way of doing things. You're not actually having people try and manipulate the network to their favor, but that would require some sort of.
It's not a Byzantine fault tolerance simulation. It's what did you say?
Crash fault tolerant.
crash fault tolerance simulation. In the simulations, what I do is I don't simulate always the same nodes to be fault tolerance. I just randomly jump around. So I also do that, or the other way around. And so for me, this was really enough to convince myself that Avalanche has a huge potential. And I essentially just waited then 2 years to take part in the ICO. And I tried to reach out to you guys to join you before you go to the ICO, so I could get into the team. But Team Rocket wasn't talking, and that was the thing.
Right. So one thing I want to point out with what I said before is that the number of nodes. I want to notice just this graph here on the bottom right hand side, the sample 10 graph. Okay, I want you to notice round 11 on the 100,000. Okay, and then we go up a factor of 10 million. To the 1 million. And I want you to notice that it's the 13th round on a million looks very similar to the 100,000th round the 11th round on 100,000. And I think that just shows the scaling, the log scaling that we're dealing with here. And do you agree?
Absolutely.
Yeah, so like this mirrors what we expected the whole way. Like 13 looks exactly like 11, which just shows exactly the log scaling that we're kind of expecting to see. So your simulation does match the expected results, which is incredible. Love to see that. And if you add more nodes to the network, we'll just have to bump it out like another 2 or 3 rounds, and we've come to consensus. Still fast, It's still incredibly quick.
Yeah, I mean, these are at the moment we operate with 1,000 nodes in the mainnet, right? This is nothing. So compared to what Avalanche, this is the core algorithm. Then you have implementation details, like you have now a full graph. Everybody needs to communicate with everybody. After I think 10,000 or 100,000 nodes, everybody talking with everybody in a full graph might become problematic. Just from a socket point of view, or a technical thing. But the core algorithm can easily scale to 1 million nodes or more.
Yeah, and so what you basically said is that we're now limited by the gossip protocol more than anything else.
Yeah.
And that's true for everybody. It doesn't matter what network you would have out there, if they would run into the same limitations. But the actual Avalanche algorithm could use the gossip protocol to the maximum amount that it can. Correct? Like we're not, which I think gossip is what, n log n, isn't it? So yeah. Anyway,
I don't know. I'm not a distributed computer scientist, but I can. What I can say is. It's
So Aphex Monkey asked if these nodes have equal weight. And
yes,
they do. But does that matter?
They do. Yes, it does matter. At least in my simulations. According to Kevin, it doesn't matter.
I don't think it matters. Here's why. Because if you...
But I'm still simulating Slush and Snowflake. I didn't simulate full Avalanche yet. And I don't know if in full Avalanche I would see a difference in behavior.
Well, keep in mind, the weight is basically... So in Avalanche, you could kind of think as 1 nano of Vox as being 1 node. Even though, or 1 actor, it's not 1 node. So 1 node contains the stake, the weighting of 1 nano evox is 1 unit of weight, right? In your system, everybody has the same distribution of weight, right? But you can easily just say that, 1,000 nodes operating the same, in the same manner, be it Byzantine or not, is the same as saying X amount of weight is operating in the same manner, if that makes sense. So weight is really just measured in nano of Vox, and for this purpose, like the nodes themselves don't actually matter all that much, because it's all about how the nodes are coordinating. And if you have 1 actor that's coordinating in a particular way, then you're doing a Byzantine modeling, right? Does that make sense? So like if they're all equal weight, you could just say that they all have the stake of 1 nano of Vox and it's equivalent. But if like 30 of the nodes or 30% of the stake is operating in the same way. We could just assume that it's one actor, one person that's doing all of that. Does that make sense? Or one cabal of people. And so the actual weight of the nodes doesn't matter for the consensus. The consensus only cares what the distribution of Byzantine behavior is.
There is one point. In the most recent implementation of the simulator, I implemented simulating various stake distributions.
Okay.
Including, you can also feed it the most recent mainnet distribution.
Okay.
And as long as you have well-behaved distributions like I don't know, the normal distribution or the gamma distribution, or all these well-behaved distributions, or the uniform distribution. Uniform distribution is where you just randomly assign nodes various stakes. None of that matters. But if you assign according to the Cauchy distribution or the Pareto distribution is like this 80-20 rule, where 20% own most of the stakes, and you have or stuff like that. Then you see that these outliers they take longer. So in those cases, what you need to do is you really have to actively counteract those distributions. And the reason is, I talked in my thread about this. There is a law of large numbers. This law of large numbers is a statistical thing. When you do probabilistic experiments, these probabilistic experiments lead to a result, lead to an expectation only when the underlying distribution has itself an expectation. But for example, the Pareto, this is very mathematical, but the Pareto and Cauchy distributions, they don't have expectations. They just don't. And in those cases, Avalanche takes longer. So we don't see that yet in the main network, because the distribution we have is has nothing to do with these. I call them how do you call them? Bad distributions, and they are quite hypothetical. For example, Pareto 1 distribution is really just many almost having nothing, and then it just goes up. And I could show you in my Twitter thread later on, maybe if you have my. I don't know if I can pull this up. Or
yeah, send me the link. I'll share it. Or send chat link, and I'll put it up myself.
Yeah, if I can show this, but the gist is, I'm not sure if I can find it now. The point is, in those cases, it takes longer for these outliers to vanish. You need to do more than 20 rounds. And Avalanche is able to do that, right? So liveness gets a little bit suffers, and in those cases you just have to iterate for more rounds until you have your enough chits. And to avoid these cases and to improve liveness, at some point I think you guys have to start mapping. You have now a one-to-one mapping from stakes to rewards, to voting power. This is all proportional at the moment. And at some point, the voting power, if you want to avoid these Pareto and Cauchy distribution kind of situations and improve liveness, you have to, for example, take not maybe the square root, but maybe the three or fourth power, something like that, to avoid those cases. Kind of staking with a virtual voting power, which is not proportional to your actual staking. But I mean, this is something.
But that's the thing. It's like it shouldn't matter too much, because the decision power. It's like, again, you can take any like, let's say you got 1 million nodes. You can take any percentage of those nodes and say they are acting as one actor, right? It's equivalent if they're all equally staked. Then does that make sense? So like, I think that you're just testing the actual Byzantine part of it at that point. You're not actually, which is great. We need that. So, I mean, I'm glad you're doing it. But I would be interested to see how those particular distributions of poor stake actually delay consensus. But I think we all can kind of see that they're going to come to consensus.
Yeah, they are going to come consensus, but I mean, if you want to improve liveness in those, but look at these cases, Cauchy distribution and Pareto distribution, one over. These are highly theoretical distributions. You will almost never see them in a real life situation. Because to set up such distributions, you have to buy all these stakes, right, and distribute it accordingly, and that takes a lot of money and engineering to get that right. So
plus, one person that just drops more stake into the network changes the whole equation, right? They would have to be able to literally do a complete halt on liveness on a particular staking transaction to prevent that from happening. So, like, it's actually solvable just by somebody joining the network.
That's one thing, and the network knows the entire stake, right? So the network can, or the stake distribution, the network knows the entire stake distribution. So what you could easily do is you just get some statistical measure about how skewed the distribution is, or and depending on that, you start applying adaptive countermeasures where this your voting power gets decoupled from the staking power to keep liveness.
But then again, like the question is, how much liveness problems will we be facing? And this is still theoretical in and of itself. So
it's theoretical. It's theoretical. What the situation?
And it wouldn't be like exponentially increasing liveness problem for a particular. By the way, for a particular decision, and they have to be voting in a Byzantine manner to specifically delay a specific transaction. So it would have to be like, nobody can join the network at all during this time period. It would have to be a very specific amount of stake, and they would have to actually have and not only that, but like, this is theoretical. I'm not even sure this actually happens. So you still need to model this, correct?
Yeah. I have worked with Slush and Snowflake. I haven't implemented Avalanche itself. So for this to be clear, I'm talking, all my statements are about Slush and Snowflake. But Snowflake is the basis of Avalanche, right?
Yeah.
So with Snowflake, you pretty much can make qualitative statements about Avalanche, and it's just something. In my opinion, it's a theoretical edge case, and it's very easily solvable with I call this, virtual voting power, real-time virtual voting power stake adaptation. It's a complicated name and nobody understands it, but
I get it.
But
I'm not actually convinced it's necessary. I really don't, because you'd have to have a really tightly controlled system, and I don't think I'm not even sure it actually happens in reality. Like, I really want to see, like, I mean, like, not even reality. I'm not even sure it happens in your models yet. Like, have you ever been able to simulate this in Snowflake?
Yes.
Oh, you have?
I saw this.
Oh, okay.
I saw this. Yeah. I saw this.
But how much was the delay? What was the liveness impact of that?
I didn't quantify it. If I can find you the graphs, I will show it to you. Just a second. Where is it? Maybe Pareto. Yeah. Pareto. Yes. Here it is. Pareto and Cauchy. Okay, I have two threads. One is about this, and the other one is about this. It's the same. Okay, if you check out here, where shall I drop this? Where are you?
In chat. Just drop it in a stream chat.
Yeah, it's a Twitter thread. Now, if you can open it, so I can. Do you see it?
Let's see. Let me pop this over. By the way, to anybody who's just joined, the stream was a little scuffed today, so I'm happy to go over and talk more about transaction formats. So, okay, so what do you... yes, I remember this. Oh, do you not see it on the...
No,
oh, sorry. Yeah, I got a screen share. My bad. Here we go.
Yeah.
All right, my bad.
So the first screenshot, if you could open that, you see there the first screenshot is just uniform distribution, and you see uniform distribution is not equal distribution. Some people have less, some people have more. It's a uniform distribution of stakes, and in those cases, Avalanche is really fast. Look at it. After 3 rounds, there are no outliers. With a crash fall tolerance of and 15% error, everything is tight. So everything just works out. And if you open then the next graph here you have what is it, the Cauchy or Pareto distribution. This is the Pareto distribution, and the same situation, and you see those outliers. And you see those outliers, and this is the Pareto distribution, Pareto 1 it's called. And the Pareto 1 distribution is really like a lot of people have almost nothing, and then it just spikes, and then it just spikes. And the way to solve this is you just take, instead of for example, the 3/4 power of the Pareto distribution. That's the next screenshot below. If you go below there, you see the outliers at 20, at the round 20.
Yep.
Those outliers are gone. Those outliers are gone. So in these bad cases, you have to do voting power adaptation. And the reason is just the law of large numbers. The law of large numbers simply doesn't work in some bad distributions, and in those cases you have to adapt. But at the current stake distribution, these are all theoretical discussions, so I don't want anybody to get some fault out of this.
This is not fun. This is an examination on weird edge cases that still might exist in the client, might not. So I don't know if this is something I can ask Steven about if we're actually looking into this. It's good to know about, but I think, okay, so you're saying that after round 20 with a 3/4 power of the Pareto distribution squared, double squared root of cube stake.
Yeah, and this is for 10,000 nodes, 10,000 nodes, 1,000 simulations, 15% crash fall tolerant. I took Pareto distributions, and then I had some outliers after around 20, and then I just modified this Pareto distribution by you could have taken the square root, but taking the square root of all staking powers is quite drastic, right? It's like you just take the biggest stake, and then you just count it a square root and so on, and that's quite a drastic adaptation to the.
So here's the other thing to point out is that, by the way, you've only done 20 rounds, but the network keeps going until it comes to consensus, right? Until you get beta.
In the simulations, you can increase the rounds. You can go up to its parameterizable. But I just wanted to work always with these 20 rounds to see, to make a comparison.
So what I want to point out, though, is that these outliers don't mean that these outliers never come to consensus. They come to consensus in like 5 rounds more or something like that, if that makes sense. Like this outlier ended at 20. There's no, with your power distribution, it ended faster within 20 rounds across everything. Of course, you'd have to look into what actually means, or how that impacts staking distribution, that kind of thing. But it is an interesting thing to look into, and it's a good thing to propose. But I also want to point out that with the current system, even as it is currently implemented, these outliers will eventually come to consensus. You just have to do it in more rounds. And it's not that significant of an increase in time to consensus. It basically says that this one might come to consensus in 10 more rounds.
You can count them. There are 3 outliers here out of 1,000 simulations, all right? So if you would do maybe one more round, they would be gone. So and that's what Avalanche is doing. So if anybody comes and says, "Oh, look, Avalanche won't get, won't Avalanche cannot get to liveness," that's not true. Avalanche eventually will get to liveness,
Right.
and to maintain, but if you want to speed it up, you have to start playing these mapping games between staking power and voting power, in
Okay.
which case you can speed up the network, because Avalanche works best when staking power is uniform or equal. But then I actually fed the actual distributions which we have today today in the network. It's not in the graph. I did it for myself, and that's something else. And it's like the uniform distribution. The distribution we have today in the network, after 3 rounds, everything is just reaches consensus. So I just want to point that out. The current distribution doesn't have any, as far as I can tell, has no impact on liveness. It's far away from Cauchy or Pareto distributions. It is skewed. That is skewed, but being skewed doesn't automatically mean that that liveness takes longer. No, it has to be a very special distribution. It's actually, in statistics, it's called fat tails. You have to have fat tails, and when you have those cases, then it takes liveness can suffer. And to avoid that, you can do, I call this weak nonlinear staking to voting power mapping. And that does the trick. It's a very simple trick, and the network can itself, in real time, always measure, oh, am I reaching towards? That's an optimization I'm essentially suggesting for an edge case that might never happen, so it might be overkill.
So I also wanted to talk a little bit about your Ginny number, if that's all right. So by the way, thank you very much. Thank you very much for your work. I appreciate the. I don't think your Ginny's wrong. I actually thought it was suspicious, and then I realized it's not, and then I realized that a tremendous amount of voting power has been dropping off before the unlock period, which happens June 9th. And I think that's in preparation to be able to react and leave optionality to price change.
I can't say. I just saw that. Everybody started noticing it. You don't have to use my graphs, right? On Avascan or Vscout, you see that the staking ratio is dropping, and either the team or somebody else is just taking away staking power. My interpretation was maybe Avalabs is selling some AVAX to some big whales or some. I'm just speculating. I have no idea.
I have no idea either, but I will say that 60 million in stake has dropped off.
Or somebody, they're just feeding the big fish. That was the first thing I thought. Or what you're saying? Maybe they just want to have some preparation extra.
Yeah, because 60 million is a lot, and I honestly, my gut instinct is telling me that this is a little more organic. I think that a lot of people are trying to. First off, the number of validators hasn't really changed
today
that
much.
Today
is 80 million, by the way. I measured it today. It's 80 million. So at the moment, it's 220 million, and just a week or 2 weeks ago, it was almost 300 million.
Yeah, that's a big
80
drop.
80 million AVAX are gone from the staking. TVL. I call it TVL. And total value locked, somebody. I thought maybe it's just because due to the upgrades that some of the validators just need maintenance. But
we have stats on that, and they look like most of the validators actually seem to move over just fine. I did notice a couple of major whales that were having problems. They had like 3 million in them. This seems like people just let things expire. So I'm not sure what that's about. We'll know after the 9th, I think, because it's probably no coincidence that this is happening right before the unlock. So I'm interested in seeing. I don't think people are going to dump. That's not my gut. My gut is that they're just trying to figure out what's going on. And I honestly have no idea. So I have no idea what's going on with that. But it does look like a ton of staking power has dropped out of the network.
I think it's a business decision. I think internally there will be some OTC trades. Again, just speculating here. I am sitting thousands of kilometers away from the Avalanche.
Yeah, I have no idea.
I don't talk to them. and maybe just some big guy said, "Oh, look, Avalanche is cool. I want to buy."
But I do want to
In
point out
bulk.
that impacts like this whole Gini score as well, right?
Absolutely, it's interesting. You know, Avalanche, in Avalanche, you want to optimize three things. You want to keep TVL high up, so a lot of money needs to be in the system, locked, right? AVAX or dollars doesn't matter, right? That's one part. You want to increase the number of validators. That's another part.
Yep.
And you want to have them more or less not equal distribution, but you want to have less skewed distribution. So bigger fish have relative to smaller fish less impact, essentially.
Right.
So it's this optimization problem where you try to optimize all three variables, and Gini is just a number which measures these. I call this imbalance. It's skewedness, how skewed the distribution is. You see it in the graph below. The graph below is the actual distribution, and the graph on the top. The
blue versus the red.
No. Blue is own stake. Red is own plus delegated stake. And there are two pictures here, right? On top and on below.
Whoops. Yep. All right. I thought they were. Yep. Got it. Okay.
So the below graph you see is the actual AVAX distribution. You see the vertical scale maxes out at 3 million. 3 million.
Yep.
And the top graph is the cumulative one. So that one maxes out at around 300 million. So everybody together, just counted together. So you want to optimize three variables in your staking system. One is you want to have a lot of money securing the network stake. So I call this TVL, total value locked. You want to have a lot of validators, more validators, the better, and you want to have a reduced influence of the bigger fish,
Right.
and that's what Gini is counting. But there is some intuitive things going on. For example, Gini can go up when you have the same set of people and the small validator joins the network. Then Gini goes actually up.
That makes sense. Yeah, because basically, guys, Gini, just to explain, is basically a measurement of wealth inequality. Essentially, it's a wealth distribution, wealth as power distribution. Okay, and 85% is approximately what the United States is currently sitting at.
Yeah.
And so that's not an abnormal number. For me, it was kind of shocking because I thought we were way more distributed than we are, but we're actually kind of matching the U.S. dollar as far as the wealth distribution in stakers. But if a small staker joins the network, the wealth distribution of the power, it actually increased to Gini, even though another validator's joined the network. So it's really interesting to see. Like, it's really a hard metric to get meaning out of in the current system.
But let me put it this way. Gini is very simple to understand. When you have when you have equal distribution, Gini is zero.
Right.
Gini is zero. Okay.
When you have one person making all the decisions, one person making all the decisions is one.
No, that's Gini one. Gini one.
Yep.
One person making all decisions.
Yep.
That's Gini 100%. 100%.
Right.
100%. So that's total centralization. And Gini 0% means essentially communism, I call it. It's just everybody being the same. But that doesn't mean if you have an 85.6% number that you can't take this like, oh, now we are 85% centralized. No, that's not the right way to think about it.
Right. So this is why this is kind of a dangerous number to use in this number.
Gini doesn't measure centralization or decentralization, but it's a proxy for it. It's a proxy. So you have to be careful. But it's one of these coefficients which can sometimes act, because the definition of Gini is the total current difference among the nodes divided by the maximum possible difference.
Right.
Maximum possible difference. That's what it is. Yeah, and when you have, for example, but you see that black bar.
Yes, that's what I was about to say. Yeah.
So 30% of the stake is on the left-hand side of that black bar, and 70% of the stake is on the right-hand side of the black bar. So
right.
You see there is a number. It's like I don't know how much is it in this particular. I can't read it here. Well, just a second. Let me.
Sorry, the LHS controls.
Yeah.
What?
Yeah, it's 800. It's almost 900. 900 validators,
yes.
Right? 900 validators are on the left-hand side, and they just cover 30% of the votes. 30% of the votes, and 70%. So we have here total almost 1,000. So 100 nodes dominate 70% of the stakes. So that's the black bar. So that's perhaps easier to visualize.
Right. Got it. So you're saying everything past this bar on the right hand side is the amount of stake owned by 70. This is a 70% of the actual staking power is in this black bar, and everything on the on the left hand side is 30%, and this is your 70-30% split. So like literally everything after this is the biggest whales in the network, and everything on this side is the less bigger whales, I guess you could say. And there's 894. When you took this data point, there's 894 nodes on this side versus that side. I'm actually interested to see if your claims are true and Ava Labs and everybody else pulled out nodes, the players pulled out nodes from the validators, okay? Then they would be, this bar would actually shift in favor of, it would shift.
Yes.
It would shift in favor of the Gini going down. Instead of it going up.
If the whales go away, if Ava Labs decides not to stake anymore, then Gini will drop drastically. I don't know who these 1 million guys are. Maybe it's Vitalik. I don't know. But it will drop. But again, it might drop. That's the counterintuitive part about the Gini, because Gini always measures the relative imbalance, right? So if the current whales go away, and you always have a whale, right, waiting next in line. So if these 1 million guys, they will suddenly will be the biggest whales. So Gini might actually drop down in this case, but you have to be careful. But what I'm saying is simple. You have to increase total value locked to secure your network. You have to increase the number of validators, and it's good for decentralization if the Gini coefficient is low.
Right.
If the coefficient low. But
I'd love to see these numbers we run today, considering that we had validators drop and stake drop.
Sorry?
I'd love to see this data run today. And the reason is because we've had a drop in validators. We've had a drop in stake.
I have it.
Oh, you do?
I tweeted about it.
Oh.
I tweet it every day.
Okay, let's see. What do you got? So that Gini is right here. So this will be the new one. So it dropped. It dropped by like 1%. Is that correct?
Yeah, something like that. And TVL is what is TVL there? It's like 220. You see, 80 million AVAX gone, and it dropped like by 1%. And you see the. I mean, the.
Hold on one second. Let me compare these two. So given the old one that you have, it was 85.6. We were going towards more decentralization at a pretty hefty rate, in my opinion. But the validators have dropped to 956, and so there's less validators. So it's pretty clear that the pool on the right-hand side is deciding not to renew stake, and the pool on the left-hand side is deciding mostly to keep stake. Is that correct, or is that even true? So let's see. This is the old one. So go ahead.
Look at the right-hand side. You see the width of the 3 million validators. Yes. It's getting less. So the big fish are not staking, and I'm guessing it's Avalanche. I don't know.
I think they probably saw your work. They've been all sharing it. I know that. So maybe they saw your work and realized that there's something there, or maybe it's not related. I don't know. I know that the plan has always been to be as decentralized as humanly possible, and I think that this metric really shows that this is going in that direction, which I'm happy about. We just got to keep monitoring it.
Yeah, and one more thing. This is the apparent Gini, right? I can only measure the Gini among validators, but I don't know which validator belongs to whom.
Right.
So the real Gini, it might be low, might be actually higher. Because if all these validators on the right hand side are controlled by a single entity, it might be actually higher. So what I can do with this Gini is just measure the lower bound. It's a lower bound. That's important. So I can't measure the actual Gini. I actually thought about creating a second graph where I can, identify you know which validator is getting rewarded to which P address, right? P chain address.
Yes.
So you could group those validators by P chain addresses and then create a second graph where you just count those as one big validator, which I haven't done yet, that thing. But it's that you can also game, right? People then just start changing their reward addresses to more. So that's something I plan to do in the future, to see if some people, just some big fish have started small, just smaller validators to just fake decentralization, to see. But you can circumvent that by just changing the reward address on the P chain to some other address.
So what you can also do is look at some of the, looks like all nodes has a tremendous amount of staked nodes, number of nodes out there. vScout has this registration.
Avascan has done a good job there. If you open Avascan, they have nice statistics about which, I call them pools. They're like pools, right?
Right.
Stats on the top.
Oh, there we go.
Stats. Okay. Yeah. You see, US is dominating, country domination you have. But this is delegated stakes. They don't do own stake. If you go down, here, you see top 10 countries by validators, top 10 countries by operators, something like this.
Right. Wow. Google's got a hefty amount. Microsoft does too. But okay, cool. I haven't checked this out in a while. That's awesome. So yeah, I mean, is there a way to find out if Avalabs nodes, which I thought was public, pretty sure they were tagged.
If you go back, it's I think called as Genesis.
You just call them Genesis entities, but that's bundling team. That's bundling people who are in.
I don't know. This is what Avalabs did. I don't know what Genesis entities.
Yeah, that doesn't mean what you think it means. That just means that anybody who had a Genesis account, and that's for instance, I'm not a member of the team. Like if I staked, I was a member of the team. If I stake with my stuff that was on Genesis, it doesn't first. It should bump, frankly, Amazon because that's where I run my host. But it shouldn't mean Avalabs. It's not the same thing. It's not equivalent.
Yeah. And nodes also doesn't mean, right? On all nodes, you have different people using all nodes and staking there. I don't know how staking on all nodes in detail works, but as far as I understand, they just operate, but people stake from their own wallets onto the node. So,
Right.
so it's not the same thing. And I read in the forums a lot of people complain about, oh look, we have all these nodes operating in the clouds. I think that's not a problem at all. If some cloud center just burns down, you just restake to some other cloud center. So
Yeah.
I don't agree with that.
Well,
I
I
don't
can give a
agree.
little insight into that. I'm pretty sure this is okay public knowledge. If not, I apologize in advance. I thought it was. But we set up our own system for Avalanche nodes, and we did use Amazon as the primary system for that. And there were hundreds of nodes, but they're distributed globally. So it was not one data center. It wasn't just Ashburn in Virginia. It wasn't just it wasn't just Oregon. It was a lot of Amazon centers. And if you look at any of the Amazon outages, now I'm certain this has been diversified since we were in talks with like Azure and stuff, which might explain the Google and the Microsoft stuff. But the Azure nodes, like this is like we tried to distribute it as much as humanly possible for a few reasons. We actually wanted global responsiveness, and it's very difficult unless you have like southern hemisphere nodes to get southern hemisphere responsiveness. We wanted the whole network to be global, and you needed to start a global network to do that. And the only way you could do that is by launching a bunch of nodes globally. And the best way to do that was to use a cloud provider. And the one that was the lowest hanging fruit is the one with the most tooling around it, which was Amazon. So of course, when we launched, we used a majority Amazon nodes. That they were distributed globally, so just lumping all Amazon Inc. into one big chunk is not a good way to look at it, because Amazon itself is very distributed.
Agree. I think country distribution geographic distribution might be actually a little bit relevant, as you said, with respect to responsiveness. But you see here, I don't understand. I heard somewhere that you guys have had validators in Singapore, but I don't see any validators operating in this graph in Singapore. Maybe they're counted under US. I don't know. I
actually don't know. I know for certain we did. I know for certain when I left we did. It was in my game plan. And like, look, you got the Singapore right Singapore. There. Okay. Yeah, like that's just the thing that Contabo GBH. What was that? Oh, that's interesting. But yeah, like literally, we tried our best. Like everybody likes to look at everybody like they're a potential villain, and like I'm gonna steal the chat myself for the second. Like everybody likes to look at the whole like these networks as like everybody's trying to do bad. But legitimately, it's against our best interest to be bad. Like, we are not trying to do anything. This is transparency, okay? We're doing our damn best. And, like, I know for certain that when I was there, it was a culture of trying to be as open and decentralized as possible given the constraints that we had, which is mostly time and resources, human capital. We did not have the people that say the Ethereum group has had for the past 6 years. They started like we did. And if you look at their early network in their first year, it was all building a human capital around themselves. Like they were trying to build a ecosystem of people who could provide data just like Hassan did. But the best part is this is that you did it on your own. Like we didn't pay you to do this. You did this all day one because you wanted it done. So I'm pretty much like up at the point where I'm just kind of like, what is this? Oh boy, is this something I'm gonna have to talk about? All right. Well, anyway, I don't want to derail too much. I'm going to talk about that in a sec because I have to look at it. But I might look at that first and then talk about it. So I don't know what's going on with that, but there's a patent. Somebody said they blocked the Avalanche patent filing, which probably could just be an injunction to block it, which is whatever. Those happen all the time. So I'll look at that. But long story short is you did great work. Your contributions are invaluable, and I really appreciate what you did. And
there's the third project I did. It was this programming this command line interface. So if anybody anybody wants to use that, I just dropped it there. If you want to work with your validator via command line interface, so I took essentially all the API endpoints and just packed them into a big bash script. So people can look at it, because I operate my self validators, and I want to use a command line tool to interact with them. And if people are interested, just have a look.
Very neat, very useful. It makes it easier to chain things together. So yeah, I appreciate your work.
Yeah. And I appreciate... You don't have to trust me. The command line interface creates just the curl command, and then you can just copy paste it. So there is no trust involved. So I tried. If you really want the command line interface to execute the command, you have to add a yes option into it. Otherwise, you just see the curl command, and you can compare it to the documentation and just run it yourself.
This is incredible. Thank you so much for adding this to the portfolio of things in the tool suite. Yeah, it's been a hard road to get this out, and I love the contributions you're adding, just intellectually and analytically, and just this tooling is amazing. Thank you.
I look. I don't know what some people get an impression. I'm a big Avalanche fan. So people.
But you have to show yourself as objective, so it's kind of tough. Yeah, I think.
I call it tough love. Tough love, because I mean you guys are. I mean you operate under the best thing you can deliver, and I look from the outside, and just because in the blockchain you have to always assume the worst, and just always argue from a devil's point of view, but that doesn't mean I actually think that you guys are the devil. That's a difference. So some people just try to hijack these Gini graphs on Twitter and just write stuff under it, which I don't agree with. But I can't every time just go and censor them. I just let them be. But so there has to be a difference between legitimate, how do you call it? Just caring about the network and creating constructive ideas, and see, oh look here, there might be something or other. I don't want to mention some other blockchain groups just drawing some thought. So I don't agree with those. And then when they come and say, oh look, Avalanche consensus doesn't work fundamentally, blah blah blah, then I get very just mad. Oh no, I totally would know where you're coming from. It's frustrating, but it's the reality we live in. You keep yourself way more composed than I do. I love to reduce myself to shouting expletives to people online. I'm not ashamed of it. There's zero shame in my game. Like if somebody's ticking me off, I'll yell at them. You stay calm and you stay clear-headed and you explain where you got your stuff from. I really appreciate everything you're doing for us, and I appreciate you coming on the show. Like this is the kind of guest that you are amazing, and you've helped me so much. I didn't really even consider the Gini of the stake distribution. It's just not my field. It's not something I need to look into. And you pointed out and said this is an area that you should be looking at. And so I did my research, and I was like, wow. So this is, remember, I started this by saying your Gini number is not incorrect. Well, it's because I looked into what you were doing, and I was like, oh, well, that actually makes more sense than I thought it did. Because I looked at the numbers the way that most people do, and thought, oh wow, they're 85% centralized, right? But that doesn't mean that. No. That's Gini is statistics about inequality, but inequality doesn't mean centralization 1-to-1. If you have full inequality, then you have centralization. If you have full equality, you have full decentralization. But the bridge from decentralization to centralization, it's I haven't looked, when it becomes centralized. So I assume you need like, I don't know, 70% of the stakes to have centralized, but that's an assumption. I don't know it. Maybe you know it better than me. I can't make a statement about this, but I put the bar at the 70% because per round you need like 70% of the peer votes to kind of get a chit. something like
Right.
that. But I don't know if that really translates one-to-one into decentralization or centralization. That I can't say.
Okay. Well, I don't think anybody could really get a good grasp on what that means, centralization. I think what we can only talk about is the thresholds in which control can be exerted over the network. And if as long as we're below those thresholds, I think we're okay. And it looks like we probably are. So I'm not that worried about it. I think that it would take a lot of people collaborating to make decisions on this network. I mean, that's what we want. That's what governance is. So thank you very much for coming on the show.
Welcome.
Thank you for pointing out all.
Welcome.
Oh, go ahead.
Yeah. Something else. I mean, even if you would have centralization, the only one who would be able to centralize now would be the Avalanche Foundation, who are interested economically to act correctly, right? To act correctly. And if they would start, censoring people, you could detect it. The smaller validators, they just issue a completely valid transaction, and if that valid transaction doesn't get through, then there is censorship going on, and then you can go and publicize it, and then the big fish would actually get an economic damage out of this. So that's one important thing. So the network is completely open and transparent, and you can observe what's going on.
Gotcha. And let's just talk. That censorship attack is the liveness threshold we've been talking about on this stream, and the safety threshold, which is the double spend thing that most people doesn't even come into the equation. There's no way that you can game the money in any other way. The only thing that might be a little bit suspicious, which I will take your word on that, is that there might be an ability to censor transactions. But I don't know. There's no real evidence of that happening or can happen at this point.
You cannot. I mean, you would need to fake signatures, which is computationally impossible. So I don't see how you would impact safety in this sense. And the other one is observable. As I said, I'm just repeating myself. So, and the gene is coming down. And to be honest, I mean, I came out very early. The network is young. This Gini number will hopefully go down over time. It's just my way of just keeping publicizing it and hoping that will create some I don't want to call it pressure, but some hint that maybe people should react.
Okay, so I'm sorry, I'm also getting inundated about patent stuff while we're talking, but I really do love the insights you bring. I think you gave a lot of people clarity on this. I'm probably going to be highlighting this talk to show some clips of what you've done. I think you've done tremendous work, so I really appreciate it. And with that, I am going to take myself a quick break, and I'm going to do what I said I was going to do. I'm going to start going over the transaction formats a little bit in Avalanche. You're happy to stick around, I hope, maybe, but thank you for coming on the air. I really appreciate you.
Welcome.
And I look forward to more of your work coming down the future. Do you want to shout out your how people can reach you?
Yeah, just Twitter Notex editor. The Notex editor is an editor I wrote for it's a blogging editor which allows you to create NFT certificates which are on Avalanche. So, by the way, so as an information.
Yep, it's very cool work too, and reach out to him on Twitter. Notex TEX editor, no T at the end, which is what I accidentally did just there, and you'll be able to find him there. He's been really open to DMs and stuff, so yeah, definitely reach out and collaborate because you are doing some amazing work. Really appreciate everything you're doing.
Okay, thank you very much.
Cool.
Thank you very much for the opportunity to talk. Okay.
Yep.
Bye.
All right, guys. So that was incredible. That was a wealth of information to anybody interested in this. This is definitely a stream to highlight or point to if you want to learn more about Avalanche. I might just take this whole interview and chop it up and put it on YouTube because that was very useful, I think, to a lot of people. Definitely appreciate Hassan coming on here, and I think we're going to probably have him on again someday, just because it was so useful. But yeah, all right, guys, I did say I was going to be here for 2 hours, and it's been 5:13, which means technically I'm over my time, but I promised I would go over some of the transaction formats. Now, I'm not going to finish this today. There's no way I could finish this today. This is something that I think could require a little more deep explanation. But what I can do today is do a little bit of an overview from a high level, so that when people want to dive into it themselves, they'll have a better understanding. And I'll go back over to some of the stuff I went earlier, but I'll try not to reiterate that too much. But if you want to give me 1 second, I am going to quickly go to the bathroom, and I will come back and go over this. So stick around. All right. Oh, what's crapping? All right, so I might have to address this now just because people are asking stuff, and I want to. So let's see. We got questions. So really informative. Blah, blah. Patent opinion isn't a patent opinion above isn't an injunction to PCT application rejection. So let's take a look. International law, patent law provides unified procedure filings for patent applications. So just so you guys know, this was brought to my attention. This thing came up. There's a question of the patentability by Cornell University. It's really the following. Its basis of report. I am not a lawyer, so I don't know what this means. But recent statement on Article 35.2 with regard to novelty, inventive step, or industrial applicability. Citations and explanations supporting such statements. So, the basis of the report and the novel, whether or not the actual patent is novel is coming under question. It looks like somebody's just arguing that. (2019), so this is from a while ago. This is sent in 2019, the 26th of July, right? Okay, so this is date of completion of this opinion was October 2019. So like I barely joined this company at this point, I want to say. So some of the claims were rejected, some were made. So here's the thing you got to realize. I'm not a lawyer. First off, I'm not. So don't ask me for an opinion that's legal. I can't do that. I don't know it. I'm not that guy. But I can say one thing I can point out. I'm going to find that. There we go. I'll find this. The date of this, the date here is 2019, okay? Like, everything here, I'm not going to be able to read all of this. All right, I don't know if I can read all of this, and I don't even think I need to. I'll tell you why. Because this is, first off, contesting stuff like this is common. It is. It's just part of the process, right? It's literally part of the process. The whole part is to discover and assign where things are, the same and where they're different, and assign rights to parties who have new and novel things that are useful and applicable to real world. Like, you can actually do stuff with it. I want to point out that this was from 2019. Okay. And this is contesting the Cornell University patent. It contests the basis of the report. It also looks at Article 35(2). With regard to novelty, it says that that particular part is not novel. It's making that claim. It's also saying that the reasoning is the basis of the opinion on box 1. This really interesting. And then all right, so I'm not going to be able to read this because I'm not qualified. I'm not that person. But I can say a couple things. I can point out that this is normal. This is part of the process. It's not unusual. This doesn't look like a very large opinion, if that makes sense. And it's from 2019. Like, I joined the company a month after this was filed. Okay? Like, I joined the company after this was filed. So what are you saying, right? Some are independent claims and some are dependent on the rest. All independent claims were rejected. There was no response filed by Cornell to this. The USPTO will consider this report in their judgment of the patent application. So this is like irrelevant. This is like only just used in the patent application, but it doesn't mean anything's gotten rejected. This is from a long time ago. And if you notice that the application's publication is April 22nd, 2021 is when this was published. So it's not like they're behaving as though they're not confident in this. But again, I am not a lawyer. I can't tell you for certain. So there's a PCT filed 22. Yes, like this has already been kind of public. This looks like the same thing. Is that right? PCT, how do I see that? 31506, so it's the application number. Got it. Okay, cool. So like this is the date, I think, from here where we see. So like, look, I mean, this is the way I look at it. I think that this isn't going to do much, but I don't know what the claim is. I'm gonna have to dig in to see if that's even interesting. But I do want to point out that this is continuing. Definition of independent comes from the original patent filing. So, Aradane, what are you actually saying here? Can you say it clearly? Are you saying that this particular part right here doesn't look promising? Or are you saying that this whole patent doesn't look promising? Claims 1, 2, 22, and 25 from the originally filed are independent claims. And all independent claims were rejected. All right. The whole patent doesn't look promising, huh? So you're saying that Avalanche can't be patented is what you think, huh? Why? Let's see. So 22. Again, I'm not a lawyer. I don't know what this is. Processes and consensus for metastable Byzantine agreement and illustrative body of the system, blah, 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 blah. Since the protocol nodes are configured to communicate with another over a network, the system plurality of clients, including client deserves blah, 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 blah. That's not what this is it? Interesting. Well, that could be possible. That is something that could happen. It's interesting to see how that plays out, but I don't know. I'm not a lawyer, so I can't say. I'd be surprised if it's not patentable, considering that a one-click patent is patentable. One-click purchasing was patentable. I'd be very shocked to see that this is reduced to something less than that. But whatever, we'll see. Like, I'd be interested to see what the reasoning for the patent not going through is. Yeah, I don't know. There's a lot going on here. So I can't really say for certain. I know that this is very old. I don't know what your background is, Ardane. Amazon already did it, is what you're telling me? Where? They already do this? They already come to consensus at this scale and they decided not to. Includes computer devices 3000 depicted in blah blah blah. A computer program product complaining non-transitory processor related storage have been stored there in program or one or more software programs wherein the program code when executed by the first processing node. When executed on more processors, the server implementing the polling agent, first processing node, blah 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 blah. I don't know. Configured participating in a consensus protocol with additional processing nodes. Maybe reconciled. I have no idea. Well, here's the thing. Did they file a patent? Is this related to a patent from Amazon? So remember, we're first to file, not first to, actually internationally, it's first to file. It's not first to invent. So the question is, what patent are they not? So that is this? I don't know. I can't read this. I'm not going to do this on air. Okay. What's the patent number on that? Yeah, where is that? All right, well, I'm going to have to move on from this topic. I do want to know more about this topic, though. Yeah, I'm going to have to move on from this topic. That's interesting to me. But we'll see where that goes. So, okay. Let's talk a little bit more about transaction formats. And I won't go too deep in this because we are kind of like over time and I am getting a little tired. But the first thing to point out is, again, we're a UTXO model system. So everything that we do has inputs and outputs. And the inputs to every transaction in the network is a UTXO that is in the data set already. Okay. I really got derailed by that whole patent thing. I'm actually more interested in that than this. And so since this is kind of like my show, I'm like, oh, geez, do I go with what I'm interested in or what you guys want? So the question now is, what do you guys want? There's eight of you on here right now, I think. So if you want to talk about the patent, we can talk about the patent. But I'm a little skittish about talking about it simply because I don't know. I'm not a legal opinion guy, and it feels like it's getting into that territory. So I have to be careful with regard to that stuff. I've been careful before, and this is sudden, so I didn't figure out how I'm going to be careful this time. Yeah, patents are interesting to me. I actually worked for a patent company for a hot minute, and yeah, they had some patent management company. Did some contracting work for them. interesting field. Wouldn't say I came out with more knowledge, but I don't think I could ever be an expert. There's a lot of moving parts in that system. A lot of code there that I don't know. Yeah, I honestly only responded because it was something that needed to be responded to. So when it comes to the patent stuff, the reason, first off, you guys means that I am not a representative of Avalabs or the Avalanche Foundation. This puts me in kind of a unique position where a lot of the stuff that they have to be radio silent on, I can at least try to respond to. This was not by design, by the way. It just kind of worked out that way. But I can kind of respond to patent stuff, and they can't even respond to me about it. So if I ask them about patent stuff, they can't say S to me. They can't say anything to me. They can't talk to me about it because I'm not a member of the company. And if they did, it would put whoever told me that it kind of like in a risky situation. And nobody wants to take that risk for little old me, you know? So there's no barrier for me. I can just address things as I can. I can say this. They're continuing to pursue this application. Okay? This filing happened before I joined the company. Okay? And by me, I'm not a leaking pipe if I don't get any fluid in me. That sounded gross. But literally, I can't leak something I don't know. And I will testify under oath, I don't know doo-doo about any of this, okay? So you knew when I knew. But because I'm not a member of the company, but I do have history, and I can talk about like the sentiment I got when I worked there. Because I was never part of the senior executives. Like, I never dealt with anything with regard to patents. I never had to do any of that. I could respond to it because I could go, oh, well, you know, I heard something like this might be going on. Since you've got the thing public, now I can say, okay, something like this was going on. Since it's public, he's literally found it and linked it. I could go, yeah. But I don't have like inside information about the progress of it or anything like that. I just knew it was kind of going on. So when I see stuff like this, I just have to go, okay, I'm not a legal expert. It's interesting. It's something to talk about. Can the tech be defended, right? It's a topic for my stream. As a news reporter, sort of, I'm responsibly disclosing my sources, and they are the same as yours. I don't have any inside information. So, but also I got like a responsibility not to go to experts, like topical experts, about this stuff. And I'm kind of a pundit territory at this point, which means I got to be like very careful about what I say and what I do not say. I can't straight lie to you. I don't know what this means. I don't know if this means that it's good or bad, but I can point out, I don't know who Orodane is either, who's in our chat. I can point out that the application has this filing from Amazon is from 2019, a month before I joined the company. Okay? And the filing is from May 2019, and progress has been made since then and uninhibited by the company, by the network, by development. And if you look at the patent application publication, yes, this is the US version of that, fine. But US also, like, the US patent system also exists within the international patent system. So I'll be very surprised, by the way, also if Amazon didn't, if they had some sort of patent that conflicted with ours, they didn't also do it in the US too. Like, you know, I'd be really surprised. But, you know, this is much later, and there's progress still being made, and with regard to this. So I wouldn't take this that seriously, and I'm just saying that as a non-legal expert, unless you actually talk to an actual legal expert and they go, this is very serious, which to me would say, if this is very serious, they would have stopped back in 2019, or there would be a loud fight around this. But I don't see anything like that. Maybe there is behind the scenes. Maybe they both decided to go behind the scenes on that one. But at this point, I don't see there any stopping. This publish happened in April of 22nd of 2021, and they could have not gone that route, right? What international rejection? See, what international rejection are you talking about? There's no international rejection. Like, I don't see any international rejection here. Like, this is not a rejection. This is a preliminary report on patentability. This is not, like, where is there an international rejection? Like, this is not that. It's flat out not that. I don't think it is. Like, written opinion of the International Searching Authority. Like, this is this is like appealable, by the way. This is from a long time ago. You know? Like, a lot of people contest your stuff, and a lot of people who aren't necessarily the experts will, let's see, page 4. I don't know. Again, I can't say. I'm not a legal expert, but I don't see anything that says this is like a final rejection. Like, this was put forth. This is a preliminary report on patentability. This is not the same thing as like a final decision on anything. This is a, hey, we found this. Do you want to comment on it before, we need you to comment on this. Is this the same thing? And then you got to defend that it's not the same thing. You know what I mean? That's my guess on what this is based off of my understanding of the English language. Well, I don't know if they did or not. Like, all right. Well, guys, I think we derailed. So I made a promise that I was going to go on the transaction thing. It's pretty clear that chat's really interested in the patent thing, and I am too, but I'm going to get myself in trouble if I do the patent thing. That's what my gut is telling me right now. If I keep pursuing this line of stuff, I'm going to say something that I probably shouldn't say. I might have already done that. I don't know. I'm just a guy. So, like, I don't think that this means that, and I don't know if there's been I can't listen to this you in chat that says there hasn't been an appeal to this. I can't say that there hasn't or has or has not, right? Like, I don't have the ability to make that assessment. So I don't know you. And I mean, like, I think that it probably would be interesting to me if this would pass in the United States but fail internationally. Does that make sense? Maybe that happens a lot. I don't know. Again, I don't know. But to me, I don't know if the patent has been completely, like, rejected, or if this is just them asking for feedback, or if there was another means in which to do this. Or they could have just summarily just gone, we don't need to address this, continue with the application. Like, I don't know. I don't know how any of that works. Yeah, I don't know. I'm trying to find out. I hope it does, not just for my own interest, but because I don't want people like Ripple using it yet. I know that's greedy. I don't care. Like, I don't think Ripple would be the best people to do this. Like, I don't personally want them doing it, right? Like, I don't want, like, I don't want the Ethereum guys doing this. Like, I not yet. They've not been great with stuff. Like, I like them, but like, they don't deliver. And they make a bunch of promises, and then when something good comes along, they're just going to do that. It's like, whoa, you guys did nothing to make this happen. Like, I want to see the people who know this and understand it the best to be rewarded for it by doing the best work that they can and making it go. And I also think that they're the best ones to sort of protected on an enterprise level. So that's the part that I actually think Avalanche serves a function as, enterprise. Obviously, if you run an open and permissionless network, anybody can start making a, yes, we did. We took the EVM. Correct. Totally different scenario. Totally different scenario. We literally took their code and used it as a library. Like, the EVM itself has been used by everyone. They LGPL'd it, and by the way, you could do that with our client as well. Anybody can throw up an Avalanche thing. What bothers me is enterprise integration. I feel like Ava Labs has some right to do that. I don't know. Yeah, they did. They recruited Block One's lawyer, who's from the, who's Block One was Thiel's group, or I guess he was just an investor. I'm not sure. I can't remember now. But Block One's lawyer has come on for Ava Labs. Lee Schneider, I think his name is, which kind of sounds like lead singer of Twisted Sister, Lee Schneider. Anyway, so look, I don't know what the patent stuff is. Okay, I don't know what this is. I'm happy to bring on an actual expert to make comments of it. Like, if somebody wants to talk about that, they can. To my knowledge, I don't know of any relationship between Thiel and Ava Labs, other than the fact that there's been a lot of cross correlation, cross pollination with his name in the news and Ava Labs and Avalanche. But there's also been other people like that, so it's not that telling. Other than PayPal, who he's no longer CEO of, has also tried to look at Ava Labs for a stablecoin as a stablecoin technology. So, but yeah, I don't know what this is. I don't know what this is. I'd be happy to have a legal expert come on and give me their opinion on it so that I can ask them questions. But I'm not that person, and by me doing that, I might put myself at risk of practicing law without a license, which is something you don't want to do. So I'm not going to do that on air. Okay, please understand. My instinct is to dissect the crap out of this in front of y'all and literally try and figure out what's actually going on here, because, I suspect that this is not like a blocker. But, I can't do that right now. I can't learn patent law on the air. Sorry. But it is interesting. Glad you pointed that out. I'm definitely going to be looking into this more. And I'm exhausted, guys. Like, this is exhausting me. I have a long stream, and that was a really good interview, but I can't talk for 2 hours straight. And it's tough. So I am going overtime right now. I do want to go over the transaction format stuff, but I think I might have to push that off to Friday. I might do a Friday episode just to go over some of this, or I could push it off next week. I did not expect to have the technical difficulties I did earlier, and Hassan's interview was really good, and I didn't want to stop that. So I'm going to stop here, but I will say this. The transaction format for the X-Chain really not that bad, but it does kind of like telescope outward in, and you have to have the fundamental concepts. So we'll go over some of those fundamental concepts at another date. But if you're looking to break in right now, I would say if you look at the signed transaction, that's the whole package you send. Okay? And if you just an example how this telescoping effect works, it starts with the codec ID, always, which the codec is what version kind of a version ID almost of what the transaction formats kind of are. And then that's for backwards compatibility. And then you have the unsigned transaction and the credentials at the very end of that. So the credentials actually sign the unsigned transaction. So you take the whole unsigned transaction, you hash that, you sign that, and that's your credential array of the people who are valid to actually sign it. And the interesting part is that that's kind of referenced inside the unsigned transaction itself. And then you've got unsigned transactions, and there's all sorts of different types of those. You got your base transaction. You have which is you referenced in other places. So actually your base transaction is sort of the the starting point to look at there. You can actually see that a base transaction is included in, say, a create asset transaction, right? It's the base of how that would actually work. But that's not true for all transactions. And so it's going to be a lot to parse through this transaction format. It's actually kind of complicated. And I'm going to take some time to actually do that at some point. Probably next Wednesday. Maybe Friday, if I got it in me to do it. But this is a good start, to understanding the X chain and how it's actually built. And one other thing you need to know is that the way this is structured for these transaction types is that they're canonical. So that means you can only build any given transaction in one way only and be valid, meaning that it will do exactly what you want it to. There's no way you can swap the order of things or do things. Everything is lexicographically sorted in arrays. All things are absolutely in order. So I would also hope that anybody who's doing independent research on this does that with that in mind and understands that everything is exactly in the position that it's supposed to be every single time. So with that, guys, I'm going to let you go. It's kind of late, and it's like 5:44, and the stream is supposed to end at 5. So I'm happy with the amount of content we produced out today, but I'm getting a little scuffed myself. Whew, what a long day, man! That was a rough start. I need to get those bugs worked out, and then also working with Hassan, it was like he couldn't get on, and the voice stuff. I'll figure this stuff out. I'll get into my groove. This is why I haven't asked a lot of people from the Avalanche team to come on. I actually have a tentative yes from Goon for July to come on, but I do want to get into the groove and make sure that I have a more smooth procedure for all this stuff. Before I can start bringing on the cool folks. By the way, I didn't mean that for you, Hassan. You're definitely cool. I just meant like bringing on like the heads of Ava Labs, who I really want to make sure have the smoothest experience possible. All right, guys. Thank you very much for pointing out the patent stuff. I'm gonna have to look into that personally, and I look forward to seeing you guys next time. I really do love all of you. Remember to smash that like button and subscribe. And I'll see you tomorrow, where we talk, same time, same bat channel, where we talk about just the general ecosystem or anything we want. It's a free-for-all. If we want to talk about transaction formats tomorrow, we can. But I suspect, just given the numbers of viewers on these chats, Thursday seems to be like the bigger day. Like, people like the overall ecosystem, the high-level talks. Friday was actually the biggest day I had with the IOTA folks. So... I really feel like Thursday's the bigger day to be talking about anything, and a lot of the technical stuff just needs to be mixed in instead of the full topical. So Wednesdays are the low view days. I'm fine with that, but we should definitely talk about the overall ecosystem tomorrow, 3 p.m. I'll be here, and I hope you are too. So thanks for coming on. See you later.